The question number 6 says a body of mass 3 kg is moving with the speed of 8 meter per second. The body strikes with an identical body initially at rest in such a way that after the collision, the direction of each ball makes angle 30 degree with the initial direction of motion. The total kinetic energy of the balls after the collision is. Now, see what is given, that this is the body with mass of 3 kg and this body is moving with the speed of 8 meter per second. And the second body was at rest, and after this these two bodies are moving with velocity say v1 and v2 and each with the angle of theta, and both body have equal masses of m each, which is equal to 3 kg. Right. Now we'll conserve the momentum. So by linear momentum conservation, I take as initial direction as x-axis and perpendicular to this as y-axis. Then along x-axis 3 into 8 should be equal to 3 into velocity into cos of 30 degree plus second again 3 into v2 and cos of 30 degree. This is one equation. Now along y-axis the initial momentum was 0. Now what would this? That is 3 into v1 and a sine of 30, and this is in the downward direction. So this would be minus of 3 of v2 into sine of 30. So what do you get from here? That v1 is equal to v2. I'll fill in first equation. So 24 is equal to 3 v1 cos 30 plus 3 v1 cos of 30, and that become equal to 6 v1 cos of 30, and that is equal to 24. And cos 30 is how much? The cos 30 is equal to root of 3 by 2. So let's find the value. Then v1, which is also equal to v2, and that is coming equal to 8 divided by root of 3. Now the question asks is what is the kinetic energy and what is the final kinetic energy. So kinetic energy is equal to 1 by 2. The mass is 3 plus 3 because both have equal same speed, and velocity 8 root 3 square. So 1 by 2 into 6 into 64 by 3, and so this cancel out, and so it is 64 joule. So the answer, the final kinetic energy is 64 joule. So answer to this question is the fourth option. The question number 7 says that 3 identical bricks, each of length L and mass m, are arranged as shown from a wall. The horizontal distance of center of mass of the system from the wall. Now you have to draw the diagram, and if you look at the first mass, this one, so this mass is at the distance of L by 2 from the wall. The second mass will have center mass at this position, and from here it will be at the distance of L. And third, see this distance is L by 4 and the center mass will be here, which will be L by 4 from here. So this will again be equal to L by 4, and from here this distance become L plus L by 4, which is equal to 5L by 4. Now you know the x coordinate is equal to mass into first length plus mass into second distance, and second distance is equal to L plus mass into third distance, which is equal to 5L by 4 divided by m plus m plus m. That's the location of x coordinate of center of mass. So solve this question, then XIM comes to be equal to 11 by 12 of L. So that's the answer. So second option is the correct option. The question number 8 is 2 men are carrying a uniform bar of length L on their shoulders. The bar is held horizontal such that the younger man gets 1/4 of the load. Suppose the younger man is at one end of the bar, the distance of the other man from the second end. Now dear student, what is this? That this was the beam with load of W with the length of L. One man is keeping the beam horizontal by exerting 4 air, and this force is given equal to W by 4. Now is asking that from this end what should be the location of the second one. which is carrying the rest of the load, which will equal to 3W by 4. You have to find the distance x such that this beam is horizontal. Now see how I have written these equations. W should be equal to this plus this, and this was given for the boy, one man, which was getting at W by 4, and second 3W by 4. Now the beam is horizontal, so you can take torque about this point or you can take torque about this point. So I take the torque, this is the one man, this is the second man, and this is the center of beam. So to be horizontal, so torque about any point should be equal to 0. And I take, say, the torque of this one and see how much is this distance. This is L minus X. Now take the torque about the point B. Torque about B. So that is equal to W by 4 multiplied by L minus X. And this direction is the clockwise, which I can take, say, negative. And the torque of this one about this point is equal to W into this distance is equal to L by 2 minus X, and that should be equal to 0. So solve for this. So W by 4 into L minus X is equal to W into L by 2 minus X. So W cancel with this, then X comes to be L by 3. So this distance is L by 3. Therefore the correct option to this is option number 1. Now see, the question number 9 is select the correct option about the oscillation of a body in damped oscillation. So you have to read the first option, that amplitude of oscillation of the body decreases with time. The amplitude of oscillation of body increases with time. The amplitude of oscillation of body remain constant with time. None of these. So see, when it is damped oscillation, so in damped oscillation what happened, that in each oscillation the energy decreases, and therefore the amplitude, the continuously decreases. No doubt the time period will remain almost the same. So you see that at each moment the amplitude is decreasing with time. So the correct option is the first one, because energy is dissipated in the form of heat. Now question number 10 is the capacitance of a sphere A is 4 microfarad while another sphere B is 8 microfarad. If on sphere A there is a charge of 2 microcoulomb and on B charge is 4 microcoulomb, then the ratio of the potential of the spheres. Now dear student, potential is equal to the charge divided by the capacity, and V2 will be equal to the charge divided by capacity. Now what is the charge given? The charge given in the first case is 2 microcoulombs, so 2 into 10 to the power minus 6, and it has the capacity of 4 microfarad, so 4 into 10 to the power minus 6, so this is 0.5 volt. And for the second, the charge is 4 microcoulomb and its capacity is given 8 microfarad, so this is 0.5 volt. So both potentials are equal, so therefore the V1 by V2 is equal to 1. So answer to this question is option number 2.